Good morning, all. Today I'm going to start the second chapter, Classes and Objects, the building blocks of the object-oriented paradigm. Slides are visible, right? Yes, slides are visible.
Yes, ma'am.
Nihal? Okay. So in this chapter, you are going to study about introduction to classes and objects, messages and methods, class coupling and cohesion, dynamic semantics, abstract classes, roles versus classes. So first you are going to study about introduction to classes and objects. Though these things you already studied in the fourth semester itself, right? By studying the object-oriented concepts, you've already studied what are objects, what are classes, then methods, messages, and the characteristics of object-oriented programming and all, right? So once again, you're going to study the basics of classes and objects. And after that, we'll move on to the messages and methods. So first one is introduction to classes and objects. So the object-oriented paradigm uses the concepts of the classes and objects as the basic building blocks in the process of analysis, design, and implementation of the applications. Understood? So since it is the object-oriented paradigm, so in the object-oriented paradigm, that concentrates on the concepts of the classes and objects, and these objects and classes are treated as the basic building blocks of the object oriented paradigm, and these are used in the analysis, design, and implementation of the applications. We'll see what an object is. What an object is an instance of a class. Okay, an object is an instance of a class. And what that class becomes when we are grouping the similar objects, or when we are grouping the objects with the similar properties and methods, and that group is called as the class. Understood? So here the object is an instance of a class, and when we group the similar objects, or we can say the objects with similar properties and methods, and when we combine those into a group, and that group is called as the class. So then what the class is? Class is simply a collection of objects. Okay, understood? Class is a collection of objects. What type of objects we are grouping together? The objects with the similar properties and methods, those objects we are grouping together, and that forms the class. Then classes are user defined data types on which the objects are created. Okay, so what are the classes? Classes are the user defined data types on which the objects are created. And if we consider the real world example, you can give plenty of examples for the objects and classes, right? One example here we are considering is the alarm clock. So in alarm clock, you have to identify which are the objects and which are the classes. So when we say alarm clock, and generally we will have the alarm class, and in the alarm class we will have the alarm object. What an alarm object is? The physical alarm that you are holding in your hand is called as an object. Understood? Any doubt here? What an object is, or alarm object? When you hold the alarm in your hand, then that becomes the, or when you hold the alarm clock in your hand, then that becomes the object. Or if you consider the watch, when you hold the watch, then that becomes the object. Understood what an object is? Can you give other examples for object? And if you consider the class, then the general class is the alarm clock class, and the one you hold it in your hand becomes the object, right? And can you give other examples for the objects? You can consider other examples, not only the alarm clock, or if you consider the car or any other objects and classes. Can you give the example? Yes, because you already studied these concepts, right? Objects and classes. Yes, Prithvi, can you give the example for this? Object and class. Yes.
Speaker.
Yes.
Speaker, ma'am.
Peacock. Peacock is an, if you consider that as an object, then which is the class?
Bird or animal?
Yes, birds. Birds become the class, then the peacock becomes the object of the bird class. Or if you consider the fruits, Okay, any fruit you consider, if it may be the apple or the mango, each one becomes the object of the class fruit. Right, understood now what an object and what a class is. Generally class becomes the generalization of the class, and object is the instance of that class. So if you consider the peacock, peacock is a bird and it belongs to the class bird, right? Similarly, if you consider the fruit as the class, then the apple becomes the object of that particular class. Understood? Clear? The object and the class concept. Yeah. Okay. Next, we'll see the relationship between the object in this and the class is called as an instantiation relationship. So, whenever we are defining the objects and classes, there should be a relation between the object and the class, and that relationship is called as the instantiation relationship. Okay, and if you consider the example of an alarm clock object, an alarm clock object is said to be instantiated from the alarm clock class. And if you consider the peacock example of bird class, then we say that peacock is an object, right? And that is to be instantiated from the bird class. Understood? Clear now? What an instantiation relationship. Or if we consider the fruit class, then an apple is an object of the fruit class. Clear? Then apple is said to be instantiated from the fruit class. Right? Clear? Okay. And here, generally the class is said to be the generalization of all alarm clock objects in the alarm clock class. And if you consider the bird class, then the bird is said to be the generalization of all the bird classes. Okay, clear. Similarly, if you consider the fruit class, then that is the generalization of the fruit class of all the fruit objects belong to that particular class. Now you understood what the concept of object and class. So object is an instance of a class, and when we group the different objects of similar properties and methods, and that group is said to be a class, or it is simply a collection of objects. Clear? Any doubt in the concept of objects and classes?
No, ma'am.
Okay, then we'll move on to the next slide. See here, the example is given for the alarm clock. So it consisting of its object. So it is an alarm clock. It consisting of hour, minute, alarm status, alarm hour, and alarm minute. So these are the different objects of the alarm clock. Along with that, we are also having the set of functions that we'll discuss later. So here we are only concentrating on the objects and classes. If we consider the alarm clock as the generalization clock, and alarm clock becomes one of the object of alarm class, and it consisting of hour, minute, alarm status, alarm hour, alarm minute. So hour, minute means so in the clock the alarm, sorry, in the clock we are going to view the what is the hour, minute, and all, right? Alarm status means we are setting the alarm by fixing the hour value and the minute value. So an example here they are given, alarm hour is 6 and alarm minute is 0. Alarm status is on means you are setting the alarm on. So at 6 o'clock you are going to get the alarm, but what is the time now? 10:30. 10 hour 10 and minute 10:30 means it indicates that time is present time is 10:30, and you are setting the alarm for 6 o'clock. 6 and 6, it's an hour and 0 minutes. So when you put the alarm status says on, then it indicates that you are setting the alarm at 6 o'clock, but what is the present time? It is 10:30. And alarm status off means you not set any alarm, even though the time is set at 4:35 and the present time is 5:16, but alarm status is off, and in the next case alarm status is on. So based on that, you can, like that you can have many types. Okay, but here we are mainly concentrating on what an alarm is and what its objects are. Clear? Okay. And next we'll move on to the object, or the characteristics of an object, or what the object will consisting of. The object will always have four important facets. Each object should have its own identity. So that is the first important property of the object. Each object is having its own identity, and each object is identified with object identifier. Okay, that object identifier is unique in nature. And if we have n number of objects in the class, and each object is identified by a unique object identifier, so with that object identifier we are identifying a particular object. Okay, then the attributes of its class and values are those attributes. So here we are considering normally in the form of statics and dynamic nature. So the attributes of its class and values are those attributes. So then the behavior of its class and the published interface of its class. So these are the important characteristics the object must have. Means the object is having its own identity, the attributes of its class and the values of for those attributes, then the behavior of its class, then the published interface of its class. So here we are representing in terms of the implementers or the developers view and the users view. So in the case of user view, we are considering it as an interface, but in the case of implementers view, that we are considering the behavior of its class. So these are the four important characteristics the object must have. And we'll see what are the data dependencies and the functional dependencies in a procedural language as well as in the object-oriented language. So first we'll consider with the procedural language, right? So one is, there are two types of dependencies. One is the data dependency, other one is the functional dependency. Okay, one is the data dependency, other one is the functional dependency. So in case of the procedural language, it is easy to find the data dependencies on a given function. Okay, so here we are talking about the data dependencies in a procedural language. In a procedural language, finding the data dependency on a given function is easier. How we are finding the data dependency? By simply examining the implementation of the function. Means, so if we are implemented the function, by examining that function, we are going to find the data dependency in procedural language. Okay, so in a procedural language, we can easily find the data dependencies on a given function by just simply examine the implementation of the function. Then other dependency is called as the functional dependency. So in the functional dependency, here once again we are depending on the functional dependency on the data definition. Here, to find the functional dependency, we have to examine all of the code and looking for the functions on your data. Okay, clear? So in the procedural language, we are finding the data dependency by examining the implementation of the function, and functional dependencies can be uh, uh, we are finding the functional dependency by examining the all of the code that includes the functions dependent on the data. Clear? Any doubt in the data dependency and the function dependency? Here in a procedural language, we have the data dependency and the functional dependency. We are finding the data dependencies by examining the implementation of a function, and the functional dependency is found out by examining all of the code that includes the functions of the data. Understood? But in the object-oriented model, these dependencies are readily available. No need to examine the implementation of the code or the function. These dependencies, that is data dependencies and functional dependencies, are easily available in the object-oriented model. Okay. Then objects are variables of a class data type. Clear? Objects are variables of a class data type. And so when we are talking about the objects and classes, there is one important information is, or one important concept is information ID. So before going to the definition of the information ID, First, uh, we'll see the operation of a car, okay, or how the car moves. Can anybody explain that? How the car moves? So first we have to ignite the car,
Start the
right? Yes, yes. ಏನು ಜೋರಾಗಿ ಹೇಳಿ ಕೇಳಿಸ್ತಾ ಇಲ್ಲ ನಂಗೆ. Yes.
first we have to start the engine.
Okay. Next.
Um,
Next.
then we have to release the clutch, and
Clutch. Then change
then
the gear.
yeah,
Ah.
and give
Then
acceleration.
if yes, if you put your leg on the accelerator, then the car start moving. So here we are only concentrating on how the car moves from one place to another place. And when you're igniting or when you're changing the gear or when you're increasing the accelerator, we are just performing those functions. That's all. And here we are not concentrating on how actually the gear is implemented, or when you switch on the car, actually that process taking place, that we are not bothering about, right? We're only concentrating on the functions of the car. Or if you consider the example of a TV, you will switch on the TV and you want to view one particular channel, then you will press the channel number and you start viewing that. After that, if you want to change to some other channel, you are simply pressing the what channel number, right? There we are only concentrating on viewing the TV or viewing that particular channel. But actually the transmission takes place, or actually the videos are transmitted or the data is transmitted or image is transmitted, that we are not concentrating, right? Means we are only concentrating on functionality of either a car or the television, and of actually those implement details are implemented, that we are not concentrating. And those implementation details are hidden, right, from the user, right? And that is called as information hiding. Understood? Means hiding the internal details of the object, or hiding the internal operations of the internal implementation of the object is called as information hiding. Our best example is your mobile. So with your mobile, you are going to chat with your friends, or you are calling your friends, or you are listening to the music, or you are viewing the videos or images, etc. Right. So here, by using the mobile, you are simply performing different functions, and actually those functions are implemented, that details are hidden, right? Those details are hidden, our implementation details are hidden from the user, and that concept is called as information hiding. Understood? Any doubt here? What is an information hiding? So the internal details should be only visible to the list of the functions associated with their class, and the limiting access to the internal details of the object is called as information hiding. Understood? Means hiding the implementation details of the object is called as information hiding. Understood? Any doubt in this? Yes.
No, ma'am.
Niharika, Impana,
No, ma'am.
ಕೇಳಿಸ್ಕೊತಿದ್ದೀರಲ್ಲ ನನ್ನ ಕ್ಲಾಸ್?
Yes, ma'am.
ಕ್ಲಿಯರ್ ಆಗಿದೆಯಲ್ಲ? ನನ್ನ ವಾಯ್ಸ್ ಕೇಳಿಸ್ತಾ ಇದೆಯಲ್ಲ? ಎಸ್.
Yes, ma'am. Clear ಇದೆ.
Okay. So understood. Any doubt in information ID? Then data
No.
dependencies and functional dependencies in procedural language. So we are finding the data dependencies and functional dependencies in procedural language through the examining of the implementation of the function for the data dependency, and by examining all of the code and its associated functions for functional dependencies. But these two dependencies are readily available in the object oriented model. So we are not need to be worry about these two dependencies in the object oriented model, and these objects are treated as the variables of a class data type. Then hiding the accessing details or the implementation details or the internal details of the object is called as a information hiding. When we are talking about the information hiding, so it is in hiding the information or implementation details of the objects, right? And that leads to the heuristic called as heuristic 2.1. Okay, heuristic 2.1. That heuristic says that all data should be hidden within its class. So, what is heuristic 2.1? All data should be hidden within its class. If this heuristic is violated, then it leads to the difficulty in the maintenance of the application or the program. Understood? So, first heuristic says that all data should be hidden within its class, and if this is violated, means if the data is not hidden within its class, then it leads to the difficulty in the maintenance or managing the application or the program. Understood? And this says that the consistent enforcement of information hiding at the design and implementation level is responsible for a large part of the benefits of object oriented paradigm. Okay, heuristic one says that. Okay, so this is means this heuristic stress upon hiding the details at the design level as well as at the implementation level. So if we hide the details, then it leads to the benefits of object oriented paradigm. Understood? So this is the heuristic 2.1. So this stress upon the consistent enforcement of information hiding at the design level as well as at the implementation level, means we have to hide the information within its class. So if we do that, then it leads to the large part of the benefits of object oriented paradigm. But if data is made public, then it becomes difficult to determine which portion of the system's functionality is dependent on that data. For example, here we'll see this. See, if you consider the file object, here we have different file operations: open, close, gets, puts, etc. And byte offset is also there. So this is the data, and if this data we made public, then the problem arises. Okay, if you made this public, because this byte offset may belongs to any files, and that file we are going to we are trying to open or close, or we are modifying it or something something else operation we are performing with that particular file, then what happens? So then the problem arises if we made the byte offset public. So we need to avoid treating the data as public. So if data is made public, then it is difficult to determine which portion of the system functionality is dependent on that data, because we are performing the open, close, gets, puts operation on different files, and if byte offset is made public, then it is very difficult to find out for which particular file we are considering that. Okay, so hence we need to treat, or we need to define the byte offset as the private data rather than the public data. Then we can easily identify which whenever we are performing the operations for which particular file that applies to. That we can easily identify when we treat the byte offset data as the private data. If we made it public, then it's very difficult to determine which portion of the system functionality is depending on that data. Clear? So, hence the mapping of data modifications to functionality becomes identical to that in the action-oriented world. So, we are forced to examine all of the functionality in order to determine which is dependent on the public data. So, for example, here we consider this. Here we have one more example for the point object, where we are considering the x and y coordinators as the public data. Then for some other operations, these data need to be changed. Then if it is made public, then it is very difficult to find out for which particular class it belongs to. We have to check for each class where that object is created. So hence, if you made it as the private one, then it is very easy to identify for on which object we have defined that data within which particular class. We can easily identify that. Clear? So hence, we are as and when possible, it is very important to define the data as the private data rather than declaring it as a public data. So if we declare it as a public data, then it is very difficult to determine the system functionality which is depending on that particular data. Clear? So this is about heuristic one. Any doubt in this? So the heuristic one mainly concentrates on information hiding. Means it's the stress upon all the data should be hidden within its class. The means that we have to make it as a private data rather than the public data. So that enforcement that is performing, heuristic one is performing, means it is mainly concentrating on information hiding at the design level as well as at the implementation level. If you do that, then it is the major benefit in the case of object oriented paradigm. But if it is made public, then we face the problem in maintaining or managing that particular application or the program. Understood? So two examples here they have given. One is for file operations, and second one is the for the x and y coordinates that we are treating as a public data. Clear? Any doubt here? Right? Any doubt in heuristic 2.1?
No, ma'am.
Okay, so when you're talking about the heuristics, clear. So the main thing you have to remember is what it concentrates on or what it stress upon. So this single line you need to remember, that is all data should be hidden within its class. So you have to write that sentence. After that, you can explain in your own words and you can give any examples. It is not necessary that you have to give only these two examples, right? So you can give any examples related to the declaration of the public data or the private data, so that you can give your own examples. Clear? But you have to concentrate on this line. That is, all data should be hidden within its class. It is important, and based on this sentence, you can explain by your own words. Clear? Any doubt in heuristic one? No. Then we'll move on to the next topic, that is messages and methods. So once again, these things you already know, messages and methods. We'll see it once again. What are the messages and methods? Yeah. Okay. Before discussing about the definitions of the messages and methods, first we'll see how the objects are interacting together. So as we know that in a class, we will have a set of objects. Clear? In a class, we will have a set of objects and each class will interact with other classes. Okay? Or each class will have the, what we can say, it talks to other objects within a class. And here we are treating the objects as the machines, and they will carry out the operations in their public interface for anyone who makes an appropriate request. First, let us consider that in a class we have four objects: object 1, object 2, object 3, and object 4. Object 1 request to object 2. Okay, based on the object 1 request, object will carry out the operations. Clear? All of you following, right? See here, I am considering the class which consisting of set of objects. Right? Now let's consider a class which consisting of four objects: object 1, object 2, object 3, and object 4. And object 1 is making a request for object 2. Okay. Based on object request, object 2 will carry out the operations. Okay, there interactions taking place between object 1 and object 2. And how the interaction takes place? So whenever object 1 is making a request, how will it make the request? It sends message to object 2. Okay, sends the message to object 2, understands the message and according to the request in the form of a message, it performs operations. Clear now? Right? Okay. Here, objects are treated as machines in their locations for an appropriate request. Means we are treating the objects as machines, and whenever the machine request to the machine based on the request, operations will be carried out. Clear? And how the request is sent? Request will be sent in the form of a message. Okay. Now, when an object is sending the message, first it must understand the message. Clear? Because whenever the object makes the request, how it makes the request? It makes the first, before sending the message, it must understand that message. Let us consider once again the scenario: object one and object in the form of
Ma'am, we
message.
are unable to hear. It is not clear.
Bit one second. Now, okay. Clear the voice, sir. Now, is it clear? Mhm. ಹಲೋ, ಕೇಳಿಸ್ತಾ
Yes,
ಇದೆಯಾ ಈಗ?
ಹಾ
yes, ma'am.
ಕೇಳಿಸ್ತಾ ಇದೆ ಮ್ಯಾಮ್.
ಓಕೆ, ಶೇರ್ ಮಾಡ್ತೀನಿ. ನಂದು ಡಿಸ್ಕನೆಕ್ಟ್ ಆಗ್ಬಿಟ್ಟಿತ್ತು, ಪ್ರಾಬ್ಲಮ್ ಆಯ್ತು. So you were talking about messages and methods, right?
ಎಸ್ ಮ್ಯಾಮ್.
Yes. So before explaining the messages and methods, first we should know how the objects will interact together. So as I said, the class consisting of set of objects, and each object will interact together or the communicate together in order to perform a given task. So here we are treating the objects as a machine. Okay, here we are treating objects as machines, and they will carry out the operations in their public interface based on the appropriate request. Now let us consider that in a class we are having four objects: object 1, object 2, object 3, and object 4. Object 1 is making the request to object 2. Then how it makes the request? It makes the request in the form of a message. Is it clear? Similarly, let us consider that object 3 is making a request to object 4. Then how they make the request, or they send the request in the form of a message. So before sending the message for the request, each object must understand what that message is, means what that request is, because each object is sending the request in the form of a message, right? When object 1 is sending the request in the form of a message, object 1 must know what that message is, or it must understand what that message is. Similarly, here object 3 is making a request to object 4. Right. Object 3 must also understand what that request is in the form of a message. Clear? And once they send the message or the request to the object 2, so object 1 sends the request to object 2, then based on the request, then object 2 interacts with object 1, or it performs the operations. Clear? Similarly, based on the object 3 request, object 4 performs its operation. Now is it clear? So each object is interacting with other object in the form of a message. So when they are interacting together in the form of a message, each object must understand that message. Clear? So assuming that object understands the message, the object maps the message to a function called passing itself as an implied first argument. So here, once the object sends the message to another object, then we'll assume that object understands the message. Then that object maps the message to a function call, passing itself as an implied first argument. Means it maps the message to a function call by passing the argument. Understood? Now, deciding the understandability of a message is done at runtime for the interpreted language, but if it is the compiled language, then it will be understood at the compile time. ಅರ್ಥ ಆಗ್ತಿದೆಯಲ್ಲ? Following all of you, right? So when the messages are exchanged between the objects, then how the understandability takes place in case of interpreted language and in the case of compiled language. So in the case of interpreted language, it is taking at the runtime, whereas in the compiled language, it is done at the compile time. Means understanding of the message takes place at the compile time and at the runtime for the compiled language and the interpreted languages. Understood? Clear now how the messages are going to be interacted between the objects, right? Now we'll see the definition for a message. The name or prototype an object behavior is called as a message. Clear? So the name or prototype of an object behavior is called as a message. Then many object-oriented languages supports the overloaded functions or operations. We'll see that. Okay, what is overloaded functions are the operators. But here, one important characteristic of object-oriented languages, it supports the overloaded functions or overloaded operators. So here we have two classes of overloading. One is called as the intra-class overloading. Other one is inter-class overloading. So one is the inter-class overloading and second one is inter-class overloading. We'll see that what is the intra-class overloading and inter-class overloading. Now consider the example here. One is void alarm clock set time into hours into minutes. And so when we use the intra-class overloading and inter-class overloading, so we can use the intra-class overloading or inter-class overloading when two functions in the system can have the same name as long as their argument types differ. So here in the intra-class overloading, we have the same function name, but the argument types differs. See here, for the first example, void alarm clock set time integer hours into minutes, means here we are using the integer values for the hours and minutes. In the second one, it is the string type. Okay, so here even though we have the same function name set time, but the arguments are differing in these two functions, then this type of overloading is called as intra-class overloading. Understood what is intra-class overloading? So in the intra-class overloading, we can have the two functions in the system can have the same name, but their arguments differ. Okay, if the two functions have the same name but argument differs, then we say that it is a intra-class overloading. But other one is inter-class overloading. So in the next one is it is an inter-class overloading. So here you can see the a different one, it is alarm clock and other one is watch. So here we have two different, but the arguments are same, hours and the minutes arguments are same, even the function names are same, but here we are having the different objects name. Clear? Just a minute, just a minute. Visible, slides are visible, right?
Yes, ma'am.
Okay, so here we are talking about intra-class and inter-class overloading. Understood what is intra-class overloading? So in the intra-class overloading, we are having this same function name, but the arguments differ. Any doubt in this? Set time, we are having the two same function name, set time, but arguments are different. In the first one, the arguments are declared in integer, but in the second one, it is the string type. Okay, clear? The first one, the set time messages, here one takes the two integer values, integer hours and integer minutes, and second one, it is the character string. Clear? Any doubt in this intra-class overloading? But here in the second one, yes? Okay. Okay, so in the second one, it is the inter-class overloading. So we are having the same integers, right? Integer values, integer hours, integer minutes, and same functions, but it is different one, right? Here we have the watch and the alarm object. Clear? Inter-class overloading and intra-class overloading. Any doubt in this? ಕೇಳಿಸ್ತಾ ಇದೆಯಾ ಮಾತಾಡ್ತಾ ಇರೋದು?
Yes, ma'am.
Yes. Any doubt in intra-class overloading and inter-class overloading?
No, ma'am.
No, ma'am.
So related to this intra-class overloading and inter-class overloading, we will have the heuristics 2.2, 2.3 and 2.4 that we'll discuss in the next class. So today you have studied about the concepts of classes and objects, what a class is, what an object is, and what are the characteristics of objects. And next you have studied about the examples for the class and objects. And next you have studied about the information ID. Then based on that you have studied heuristic 1. Heuristic 1, stress upon hiding the data within its class. If not, then what happens, that I explained. Next I explained about the messages. What are the messages, how the objects communicate together in the form of a message. Before communicating, each object must understand what that message is. And then I explained about the message, right? Sorry, the definition of a message. The name of an object behavior is called as a message. Then object oriented programming or object oriented paradigm supports uh, overloaded functions or the operators. Here we have two types of overloading. One is called as the intra-class overloading and second one is inter-class overloading. So here the functions can have the same name. If their arguments differ, then it is called as the intra-class overloading. In the second one, even if it is same, the object names are changed, then it is called as the, sorry, if the for the inter-class overloading, if the arguments are same and if we have two different objects of the class, then it is called as the interclass overloading. Clear? Understood? Any doubt in this? Interclass and interclass overloading. So in the next class, we'll see what are the constructors, destructors, and then we'll see the heuristics for the messages and methods. Okay. Any doubt?